So right now I have this right at the edge of my paper, right? Why is it important that I put it at the edge of the paper?
So you have room.
So I have room, right? I want all this room right over here to deal with, right? Do I want to put it in the middle so I could add stuff all the way around? Imagine how confusing that would get, right? So let's put it in the corner of the paper, okay? So I'm telling you, I'm giving you the shape, and I'm giving you these shapes right here. And I want you to make me a square. So evenly separate them on the side and on the bottom. So like that. Okay. So is that a square? It is not, right? What are we missing? What is the shape of the part that we're missing? Oh, it's a square. So we're going to actually complete this square by adding another square? Ooh. How many do I need to complete it?
16.
Am I allowed to just pull 16 things out of a hat? Yes? A lot of you guys are a lot better at some of this kind of stuff if you can see something concrete. Okay? This kind of thing is called an area model. Because didn't we just find an area? Right? So let's talk about how much is here in this square area. First of all, can we prove that it's a square? How can we prove that it's a square? Each side is the same amount. Okay, so what's this side? What are we calling this length right here? Because we don't know it, right? So this is x plus 4. What length is this?
X plus 4.
X plus 4. What length is this? X plus 4. And what length is this? So if every side is the same length, by definition, that is a square. And I have completed the square, right? How big is this?
X squared.
X squared. Why is it x squared?
Because each side is x.
Each side is x, and if we're trying to find the area, I have x squared. So what I gave you in the beginning was x squared and 8x, right? What you had to add was how many?
16.
16. Okay? So what we have just created here, not only area model-wise, but algebraically, is a perfect square. Now, by definition, a square is a square, right? All the sides are the same anyways, but algebraically what we've created is a perfect square trinomial. Now, what's really cool about perfect square trinomials is that you can write them, you can factor them in a specific way, right? What multiplies to be 16 and adds to be 8? 4 and 4?
Yeah.
Oh, look at this. 4 and 4 and 4 and 4. Is that important? Okay, super important, right? I can write this as x plus 4 times x plus 4, but I know a shortcut to write x plus 4 times x plus 4, don't I? How could I write that instead? X plus 4 squared? That's important, right? Okay. So what if what I gave you was this one and these? Here's this in the corner. What do I do? Is that a square? Not yet. Add 9? Where'd you come up with 9? Well, a lot of people need to like scoot these little things down here and then count them, right? Are you going to want to have to do that every time, or are you going to want to know a shortcut? A shortcut. Now, visually you can see that this should be 9 because the length of this right here is what? 3, and the length of this right here is what? 3. So we know that we need 3 and 3, right? But could you do it without these algebra tiles? Well, we'll get there, don't worry. So what you were given was x squared plus 6x, right? And then how many red ones did I add? 9. Now, I am not using these algebra tiles like the most correct way, just for the record right now, okay? Because if I was using the most correct way, I'd be using the yellow side, because the yellow sides are considered positive. But the yellow doesn't always show up very well, so that's why I put them on red. Okay? I don't want you to get confused about that. Alright? Yes? Yes. Is that better? Sorry, they weren't exact. It's okay. What's the length of this side? X plus 3. What's the length of this side? X plus 3. How would I factor this to its binomial?
X plus 3.
Huh. Guys, if I compare that to the area model, look at the length of this side and the length of this side. How do you find the area of a square? You square the length of the side, right? Isn't that what we did? Huh. Cool. One more. What if I gave you, well, let's just get a new piece of paper. What if I gave you this blue one? And those. Could you make a square?
Yes.
Okay, one more time, talking through it. How do we do it? So I figure out how many x's I have and talk to me mathematically. See if we can choose some really good mathematical words here.
Evenly disperse the x value.
So what another word for what he's saying is what? Divide. Take what we have and divide by what? 2. Okay. So in this case 5 and 5, right?
Oh, so we have to add the little squares?
Don't you have to add the little squares to complete your square?
But
Yeah.
what I was trying to say is, like,
Uh-huh.
can you take like some of the green ones and make it into a square?
No, because the length of this side is x. And in fact, if you line some of those up, I did a minute ago, but it's not exactly 5. So we can't just guess at what it is, so we're specifically calling it x.
Oh.
Okay? So how many am I going to need to put right here?
A lot.
Yeah, 25.
In fact, 25. And where did that number come from?
5 times 5.
Yeah.
Does that number relate in any way to how many green ones I had to begin with?
Yes. I believe.
Here's what I had to begin with, right? X squared plus 10x.
Yeah.
How could I get how many little ones I'm supposed to add?
Divide the x by 2.
So divide this by 2.
And multiply multiply the 2 halves together.
So square root or square 5.
So divide this number by 2 and then square it? Is that what you're saying?
Yeah.
Yeah, I totally agree with that. Because that keeps me from having to count 25 of these and move it all up here. I know that that's going to be right because what's this length right here?
5.
And what's this length right here? 5. So do you see where that number comes from? Right there? Does that work for both of these other ones?
It did.
Divide that term by 2.
4.
Square it. Divide that term by 2.
3.
Square it. Ooh. Can I write this as its binomial? What is it as its binomial?
X plus 5.
Now, some people are trying to trying to factor that every time, but is there a quicker pattern than trying to figure out the factors? How could you get 5 from 25? Square root it. How could you get 5 from 10? Divide by 2. Isn't it the same number? So it's either half of this or the square root of that. Does that work for every one of these? Is this half of this?
Yes.
Is this the square root of this?
Yes.
Is this half of this?
Yes.
Is it the square root of this?
Yeah.
Excellent. Now we can do some work. You ready? Now we can do some work. It will be. It will be, because what she said was, what if it's not? And my statement is, it will be, because you're going to be the one writing the number there. You're going to purposely choose what number you write right there to complete that square. That third number, right? The little baby numbers, the little baby squares, I mean. Does that make sense? I guess there was one I didn't show you. Let me show you that one real quick. What if it was, wait, can we talk about this without having the blocks out? The tiles out? What if it was x squared minus 16x? Do we still divide this by 2?
Yes.
Yes, which would give me what? Negative 8. Do I still square it? Yes, which would give me what?
64.
Is it still positive? So the number that I add right here, will I always be adding that number?
Yeah.
What is negative 8 times negative 8? Positive 64. What if it was a positive 16? What's 8 times 8? Positive 64. So will I always be adding this third term?
No way.
So then what do I do when I write the binomial?
Square.
This time it's going to be minus.
Oh.
Because of that sign, right? It's got to be half of that or square root of that. Well, you know and I know that the square root of 64 is either positive 8 or negative 8. We got to look to that middle term to see what the sign should be. You okay with that? Okay, so then let's be able to work some problems with this stuff. Okay? Let's be able to work some problems. X squared plus 2x minus 6 equals 0. This is what the problems will look like. Except, doesn't that already look like something we've solved before? Yeah, when we solved it before, we just factored it and went on, didn't we? Okay, so go ahead and tell me what multiplies to be negative 6 and adds to be positive 2.
Oh. 3 and negative 1? No. What?
3 and 2.
Multiplies to be negative 6 and adds to be positive 2.
I've never.
Yeah, me neither.
Oh.
What I'm trying to get to you is I want you to realize that factoring can't be the only way I teach you how to solve quadratics. Because factoring does not always work. Sometimes we'll have to do completing the square. When we finish this unit, you're going to end up knowing like 5 different ways to solve quadratics. You already know 3. Graphing, factoring, and using square root, right? Well, here's another way, completing the square. In order to complete the square, what do I need? When you completed the square, what did I only have? I only had the x squared and the x, right? So what I need to do here is I need to get rid of this 6. So I just scratch it out?
Add.
Yes.
Oh, okay, so add 6 to both sides. I need to get it away from it. Okay? If I add 6 to both sides, I have x squared plus 2x equals 6. What did I leave?
Blank.
I left a space, right? Because what am I going to do right there?
Pick a number.
I'm going to complete my square. Just like I did with these over here, I'm going to complete my square. Okay? What goes in that blank?
1.
How do you know that?
Because half of 2 is 1 and then 1 squared is 1.
So I took this middle term, that x term, and divided by 2 and squared it. 2 divided by 2 is 1. 1 squared is 1. But I just completely changed the value of my problem. Is that allowed?
Yes.
No.
Dang it.
If I add 1
Oh, you got it.
to this side, I have to add 1 to this side. Now this is a trinomial. Where do you think I want to go now? From the trinomial to the binomial. What is the binomial that's associated with this trinomial?
Square x plus 1.
X plus 1. And where did you get that?
The
Either dividing by 2 or square rooting this one, right? Guys, some people actually factor this. They say in their head what multiplies to be 1 and adds to be 2. Is that a bad way to do it? No, as long as you realize that it has to be the same number if we're going to write it as something squared, right?
Oh, you could only factor if it equals 0.
What?
I thought you could only factor if it equals
Nah.
No.
It's okay
For
though.
the short.
What's 6 plus 1?
18.
18.
I thought you really wrote that.
No, I did not. Okay? So, guys, is this an equation I know how to solve? I even did it yesterday, right? We solved this kind of equation yesterday, didn't we? Square root? Square root? What's left on the left-hand side? X plus 1. What's left on the right-hand side? Oh, so close.
7i?
Is there a negative inside? So I don't have i's. I mean, I do, 4 of them, but yeah.
Plus or minus?
Plus or minus square root of 7. Have I solved for x?
No.
What do I have to do to solve for x? Good. So x equals plus or minus the square root of 6?
No.
1 plus or minus square root of 7.
How about negative 1 plus or minus the square root of 7?
same thing.
It's okay. The best part is I knew what you were talking about. Okay? You okay with that so far? Okay. Does it? Yeah, that's it. X equals. You ready for another one? Okay. X squared minus 10x plus 7 equals 0. So what do I want to do first?
Subtract your 7.
Subtract my 7. I want to get these two by themselves, right?
Right.
So I have x squared minus 10x equals negative 7. What's going in the blank?
Plus 1.
Plus 25. Does anyone else know how to do this besides Lane?
No.
Okay. Lane, would you be quiet for a while so other people can answer? You're not in trouble. If I add it to one side, I got to add it to the other side, right?
Wait,
So why did we pick 25?
Oh, divided 10 by 2.
Divided 10 by 2 and got 5 and squared it. 25. Okay. Now I have my trinomial. Where am I going next?
Why did we get no?
Oh, why didn't I get negative 25?
Because whenever you multiply,
What's negative 5 squared?
25.
Positive 25.
It's always a positive.
Negative 25, or negative 5 times negative 5 is positive 25, right? Now, that negative will come into play now, won't it? For my trinomial, I go to my what? Binomial? What's my binomial? X minus 5. That's when the negative comes into play right here. Equals what?
Negative 18.
Try one more time.
I mean 18.
Yep. Regular 18. How do I solve this?
Square root.
Square root. Can we skip a step here? If we're going to skip a step, I want you to pay attention real close. Okay? Left-hand side, x minus 5, right?
Right.
Right-hand side. Do you know the square root of 18? I don't either. But I recognize that 18 is divisible by 9. And I do know the square root of 9, don't I? So plus or minus, first of all. Take the square root of 9, what do you get? 3. What's left inside of this radical? The square root of 2. Remember, we talked about this several times already. That's why I thought it was okay for us to skip a step, but apparently by the looks on your face, it was not. Okay? Remember that 18 is 9 times 2. I can take the square root of 9 and get 3. I don't know the square root of 2, so I leave it as square root of 2. You okay with that? Pardon me for assuming.
about to say by minus.
Oh no,
I thought you
times.
said minus, so I got confused.
Is that better? Okay. Now what?
Minus 5, or plus 5.
Plus 5? X equals?
So is it 5 plus or minus 3 squared 2?
Yep. Very good. One more. You ready for one more? Oh, excuse me. Yeah, one more. What have you noticed about both of these problems that we've done so far?
They're squares. They
And
don't have
all of the examples that we did?
They're being minus. They don't have a coefficient.
They don't have a leading coefficient of anything else besides 1. Guess what happens in your homework?
They have a coefficient.
And in real life?
There's got problems.
There's going to be coefficients other than just 1. In order to complete the square, your leading coefficient has to be a 1, and if it's not, you have to make it be a 1. Oh, that would be a good idea, right? Here's what they did last period, and I was sad. Oh, wait, what?
You have to do both sides.
Yeah, they said, yeah, but 0 divided by 3 is just 0, so why do we even have to write it? Well, because I don't want you to get in a habit of only doing something to one side. That's why. I'm glad that you know that 0 divided by 3 is 0, but I don't want you to get in a habit of only doing stuff to one side. Okay? So when I divide everything by 3, what do I end up with?
X squared plus 4x equals 0.
Good job. It's okay. So I always check real quick in my head, is this something I can factor? Because that's way faster. What multiplies to be 5 and adds to be 4? Nothing. So let's complete the square. What do I do first? No, I promise there's nothing that multiplies to be 5 that adds to be 4. Because they both have to be positive. Okay? So subtract 5 from both sides. So x squared plus 4x equals negative 5. Fill in the blank.
Wait, 2.
Half of 4 squared. So 4. Good job. From my trinomial, I go to my binomial.
X plus 2.
X plus 2
Squared.
equals negative 1.
Oh, I didn't see 4.
It's okay. Remember, we got to add it to both sides. Now,
Square root of both sides.
square both sides. Left-hand side, I get
X plus 2.
x plus 2. Right-hand side, I get
I.
plus or minus I.
And then subtract 2.
Good. X equals?
Negative 2 plus or minus I.
Perfect.
Okay, so no matter what, the square root of negative 1 equals I.
Correct.
Anything that you do? Or
Yes.
just
Anything.
Positive 1 is 1.
Square root of positive 1 is 1. I agree with that. Square root of negative 1 is I. Up until now, we talked about the fact that we would write no real solution. Because that's true. There's not a real solution. There's an imaginary solution. And it has to do with the I. Okay? Any questions about this? If you have any, you can always ask.